Okay, let's get into it. So the table to the right shows the temperature of a solution after it has been removed from a heat source. Find the rate of change in temperature for the solution. So here we have time in minutes, so 2 minutes, 5 minutes, 8 minutes, temperature in Celsius. Now, one thing really quick to note, although they did all the work here for rate of change, I'm still going to do all the math. So here we have x, and this is y, right? These are our x values, these are our y values. So when we're working with rate of change, something that's very important to know, and here they give us, use the ordered pairs 2, 139, blah, 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 blah. So they gave us both the points that we're going to be using. So I'm going to go for it really quick. Let's do yellow. So first and foremost, they gave us 2 points. They gave us 2, 139.4. They gave us 5 and 133.1, right? 5, 1, blah, blah, blah. First thing I do is I establish this. I write x, y, right? Because this is our x values, these are our y values. These I'm going to put 1, 1, this is going to be 2, 2. So we're going to do our rate of change. Now, if you remember the formula, y equals mx plus b, and the reason I'm bringing this up because this has a lot to do with this. M, let's get rid of m really quick, or let's actually look into m. M is equal to the slope, right? And the slope is equal to rise over run, and in addition to that, it is also y2 minus y1 over x2 minus x1. So m is a lot of things. It's all 3 of these things actually, okay? So don't be like, oh my God, that's a lot to remember. No, I'm not saying they're 3 different things. It's all just one thing for each of these. All 3 of these things is what slope is. So I don't know if you noticed earlier, really quick, going back to our points, this is how we do it. So we're gonna start over here with m is equal to y2 minus y1 over x2 minus x1. Pretty simple, right? y2 minus y1, x2 minus x1. X on the bottom, y on top. So let's put it in order. So what's our y2? Y2 right here. I'm looking for x1, y1, x2. Boom. We're going to write 133.1 minus, y minus, because that's what it says here, our y1. What's our y1? 139.4. Put a line, just because there's a line. Let's go to x2. 5. Minus, because it says it right there, our x1 is 2. So that's all we've done so far. We write this guy out. Then we just plug in our values. y2 minus y1 and x2 minus x2. That's all we've done here so far. Now let's solve this straight through. 131.1 minus 139.4 is negative 6.3. Put a line. 5 minus 2, that equals 3. Let's reduce that. The answer would be negative 2.1. If you can see right here, 2.1, negative 6.3 over 3. So we know we've done everything correctly. So I just wanted to explain to you guys how this worked. Now, while we're on the note of this, remember how I told you we use this formula? So that's done. We use the formula, but remember, rise over run. Rise over run is basically y over x. Why? Because rise can only go up and down. Run can only go left and right. That's why, hint, hint, you know when we have an x and y chart, right? The x is this way, left to right, y is up and down. So that's why we call it rise over run. So in this case, our rise is 6.3 or negative 6.3, right? But this time it's going down, right? Just because negative, but our rise is this. And I told you earlier, these are our x values, these are our y. So our temperature would be the top, T-E-M-P. I'm just writing it short. Temperature is on top. And our x, remember, because y over x, so y is temperature, so y on top, x is time. Our bottom would be time, so temperature over time. So it's basically saying that our temperature is dropping 6.3 degrees every 3 minutes, right? Because our time is in minutes. So I just wanted to thoroughly explain that really quick. I know it does it here, but sometimes you can't really see all that. It just kind of gives you the work, like boom, 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 boom. That's how we got our answer. But it doesn't really explain why things are what they are. Let's go to the next one. So here, as you can see, it says the rate of change is negative 2.1. Do you remember that, right? Right here when we did that work. Let me get rid of all that. So this means that the temperature is decreasing by 2.1 degrees Celsius each time, or each minute, each minute. What do you notice? And here I think it's written, the temperature decreases negative 6.3 in 3 seconds. Yeah, temperature, negative 6.3, in 3 seconds? No, not 3 seconds, because if we go back to our previous thing, our time is in minutes, not seconds. So it's basically close enough. It would be temperature decreases 6.3 degrees Celsius, right? And I'll write that out really quick. Yeah, gotta zoom in. I'm gonna just write it short to make it easier. So I would say the temperature decreases negative 6.3 degrees Celsius in 3 minutes. Got it? That would be pretty much it. Now, let's go down here really quick, shall we? The graph at the right shows the number of gallons of water in a swimming pool as it is being filled. At what rate is the pool being filled at? Hint. Remember, rise over run, y over x. And by the way, the reason it's a triangle, it's delta. So delta means the displacement or the change of y and the change of x. So like the change of y over the change of x. That's all that means. So here they gave us 2 points once again. We're going to choose him as our first one. We're going to choose him as our second one. Why in that order? You could do it either or. The reason I do it from down to up is because 0 is down here. You agree? Right? This is 1, 2, 3, 4. It's growing from here to there. So I'm going to go in order like from closest to furthest. That's just my style of doing it. So let's do this one again. We got 2 points. We got 3,108. And our second one is what? 7,252. Now, next thing I'm going to do is x1, y1, x2, y. Oops, that looks like an x. y2. Sorry, it looks terrible, but you know what I mean. So x1, y1 because it's our first one. x2, y2 because it's our second one. Now, let's do our formula. M equals y2 minus y1, simple, x2 minus x1, right? Easy. Now let's plug in everything. So what's our y2? 252 minus, because it says it right there. What is our first y? 108. Put a line. Our second x is 7 minus, because it says it right there. And our first x is 3. So we plugged it in exactly. And I like to label things because I don't like to lose sight of how things go. I'm just going to write that really quick. So 252 minus 108. What do you think that is? 144. 7 minus 3? 4. Perfect. So our answer, oh, and if we were to go even further and reduce that, 144 divided by 4, that'd be 36. So right here is waters per gallon. So our y is water in gallons. Our x is time and minutes. So remember how it says right here, triangle y over triangle x? Our y, oops, you can't even see that. Or I'm going to do it over here. Our rise over our run. Oh my God, no one else is here to get the door. Excuse me 1 second. So, coming back to this. Our rise over our run, y over x. So what do we state that our y value is? Our y value is gallons. Our x value is time, specifically in minutes. So this means that this is 36 gallons per minute. Because, right, rise over run. Perfect. 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 Yep. Or here you wrote per. So per is the same thing as when I do this. So when I write gallons over a minute, you could just do it gallons per minute. Both are acceptable. It's just I do this because this is easier for me. And that's about it for that.